Good day to you, students, and welcome once again to another demonstration for the physics experiment. Today, in this experiment, we will be looking at one of the important characteristics of photoelectric effect. So, the photoelectric effect was actually discovered by Professor Albert Einstein during the 1912. And this particular aspect of photoelectric effect gave way to many other discoveries, such as the photovoltaic systems and so many other contributing factors towards the photoelectric devices as well. Now, our aim of this experiment would be to examine the aspects of the photoelectric effects and also to determine the experimental value of the Planck's constant H. Okay? We will compare with the theoretical value and then find the differences from your analysis of the experiment. Welcome once again. To begin with this experiment, we will require the following apparatus. First and foremost, we will require the photoelectric unit. So this is the photoelectric unit that we will be using for our experiment. And this photoelectric unit comes together with a few colors, a few filter colors for the from the rainbow spectrum that we are seeing here. Now these are labeled with the required wavelength for each of those specific colors. And we also have some apertures. These apertures basically mean a certain area through which light can pass through. And these come in various diameter as well. So these will be used for our experiment when we are conducting part B and part C of the experiment. Now to power up the lamp that we'll be using for this experiment, we've got a LED power supply. So the LED power supply is basically aimed to allow the white light to be produced on the backing plate, upon which we will be applying the filter color. So say, for example, we have got the rails on which these lamp can pass, that lamp can be fitted in. And if you're choosing a particular certain type of filter, we can use the filter color to be split between the backing plate and the white light that we have got, allowing only the red wavelength of light to pass towards the backing plate, upon which we'll be able to continue with the experiment. To continue with the procedure of this experiment, we will look at part one, which talks about the occurrence of the photoelectric effect. So to study the photoelectric effect and to see the phenomena in action, we will look at the consideration of this particular apparatus using the experiment 1AE. So what we'll do is we will turn on the switch on the dial to turn on the photoelectric unit. Next is the other two dials will be used for this particular experiment, which is the meter reading and the other one being the backing voltage. So using the meter reading, we can adjust the backing voltage or even the tube current that is present in this particular apparatus. And the other one is the adjustment dial, which we can use to adjust the backing voltage or even the tube current for this experiment. So the first and foremost uh, procedure that we'll be studying is which is the photoelectric effect. We will need to turn the backing voltage all the way down to zero. So by turning on this, we will now adjust the backing voltage. Okay, take note that there is no light present at this point in time. So what we'll do is we will adjust it all the way down to zero. Once this has been carefully adjusted to zero, then we shall um, switch the meter reading to the tube current reading in the high range, and we will simply turn on the power which illuminates the backing voltage. So it illuminates the backing plate with the light that we have fitted onto the rails of the experiment. So once we illuminate it with a white light, you should be able to see that there is a reading, a meter reading that has been shown, which indicates the presence of the emission of electrons that has been done. That means the electrons has been ejected from the valence shell of the metal plate, and by these electrons traveling to the anode part of the baking plate, we are able to see that there is a conversion of the electrons to the electrical current that has been generated. The second part of the experiment is the consideration of the Planck's constant, which we'll be trying to determine experimentally. So for this experiment, or rather this part of the experiment, what we'll do is we will choose these filter colors that has been supplied. Okay, so these are in terms of red, orange, blue, yellow, and green, etc. And we will be using each of those filter colors in the rails that has been provided so that we can achieve only a specific wavelength of light that is being received by the backing plate. So we will now choose, let's say, one of the filter colors, and we will fit it between the rails of these particular device, and we shall then turn on the power source. And once the power source has been turned on, the meter reading basically gives off a reading in terms of the value of your current. So the essential thing to do here is to adjust all these currents down to the zero mark, because we want the threshold of that backing voltage, just a certain amount of backing voltage to be present in order for the electrons to be emitted. So therefore, we will reduce these amounts of current. There are two set of currents. One is the high current and the other one being the low current. So we'll adjust the high current first. So using the high current now, we will adjust the all the way down to the zero mark. Once the high current has been adjusted to the zero mark, then we switch on to the low current, and we shall adjust the low current to the zero mark as well. Once both the currents has been adjusted successfully to the zero amounts of current or zero amounts of nanoamps, then we will use the meter reading dial and switch it back to the backing voltage. And now we can carefully record the amount of backing voltage that has been recorded. This is in terms of negative 3.43, 3 point, 0 point, or rather negative 0.342 electron volts. Okay, this is for trial number one of the red filter color that we have been using. Now the next thing is to repeat the same trial, repeat the same procedure with the red color for two more trials or three more trials to conduct or to write the data for the data table number two. Once you have finished with the red filter color, you shall then replace it with the next filter color. Okay, it's on you. You can choose either orange or yellow, etc. And you just need to simply fit it in the place where the red filter color had been previously. And you need to repeat the same procedure. What we do is we will select the high tube current. Okay, it shows a certain amount of current that is present there. We will need to adjust the backing voltage or rather the adjust dial and bring it down to the zero mark. Once the high tube current has been reduced to the zero level, then we shall choose the low tube current, and we shall adjust the low tube current down to the zero mark as well. And once both the high and low tube currents have been adjusted successfully to the zero, then we will choose the meter reading and flip it all the way to the backing voltage and record the amount of backing voltage in terms of electron volts. So in this case, it presents a negative 0.547 electron volts for the orange color. And then similarly, you need to choose the other colors that has been supplied and follow the same procedure, taking note of the amount of backing voltage in terms of electron volts, as well as the corresponding wavelengths of each of those filter colors that you're using for the experimental part number 2. Looking at the third part of the experiment, the third part considers the relationship between the illumination and current. So that means we will be varying the illumination that we are providing to the backing plate using these different apertures that we had looked at earlier. So using these different apertures, we will then allow the certain amount of light to only pass through, and which is reflected, which is captured by the backing plate, and therefore converted into the electrical current that will be produced. So to start off, what we will do is we will keep the light source in active operation when we are doing this part of the experiment. And the first and foremost thing, we will select the backing voltage. So the meter reading to be on backing voltage, and we shall adjust the backing voltage all the way down to the 0 mark. So once the backing voltage has been successfully adjusted to the 0 mark, we shall use or we shall select the tube current, select the meter reading to the tube current range, and we will fit in one of the apertures into the rails of this particular uh, uh, sensor out here. And once we have put the specific aperture into this, we shall then record the amount of illumination in terms of the high tube current. Okay, so in this case, this refers to 0.43 microamps for the 20 millimeter diameter aperture. Similarly, we will now switch between the aperture size to the next order, which is the 14 millimeter. So this is a further reduced illumination level, and the further reduced illumination level, you can see it is correlated with a lower tube current as well. Now in this case, the 14 millimeter diameter uh, continues to have a current of just about 0.4 microamps. Similarly, you can repeat it with the 10 millimeter diameter and the 7 millimeter diameter, etc. Finally, I hope you have understood the aspects of the photovoltaic effect, how we are able to explain the photovoltaic effect in terms of the illumination that is provided onto a metal surface, together with trying to determine the Planck's constant and also examine the relationship between the illumination and current that is present on the metal surface. So with this in mind, I hope you will be able to complete the rest of the analysis together with the data has been given, that has been given in these results. And I hope you will be able to also determine the experimental and and the difference between the experimental and the theoretical value of the Planck's constant always.